Alright guys, welcome back to Underground Science, and in this video we'll be talking about alkynes and mainly the basics and intro to alkynes before we actually start naming alkynes. Alright, so let's go and get started. So if we jump into the table right away like we've been doing for alkanes and alkenes, right, so it's the same thing. Once we've got this down in alkanes, it's been easy throughout because as long as you know the prefix and the suffix meaning, we're good, right? So eth means 2 carbons, prop means 3 carbons, but means 4, pent means 5, and we know the rest, right? Because we've been doing it for alkenes and alkanes now. But what we have to focus on now is the suffix "-ine", which now means that we're dealing with a triple bond. And because we're dealing with a triple bond, right, even with the double bond, we cannot have methine, right? That's why I didn't include that in the table. We cannot have methine because that would indicate there's only one carbon because of the meth prefix, and you can't have a triple bond with one carbon, right? You need at least 2 carbons to have a triple bond. And so if we start with ethyne, right, and just draw the basics of how it looks like. So ethyne would look like there's 2 carbons, right? But it's ethyne, so we know that's a triple bond. Okay, and same with propyne. Propyne would be 3 carbons, but because it's ine, we know there's a triple bond. Same with butyne. There's 4 carbons, but because there's the ine suffix, we know we're dealing with a triple bond. Same with pentyne. 1, 2, 3, 4, 5 carbons, but because it's ine, we're dealing with the triple bond. And just like that, we can write out the rest of this. And here it is, right? So now that we know these basics, what we can do is just like we did for the alkenes and alkanes, right? So if we do a quick review of that, for alkanes, what did we say the formula was in order to find the actual formula of a compound? So we said that was CnH2n plus 2, right? And then if we just draw a line of separation, what did we say the formula was for alkenes? For alkenes, we said it was CnH2n. And then for alkynes, it's going to be similar, but it's going to be CnH2n minus 2. So of course you can know these formulas in order to find the formula of a compound, but you can also do another way, which we'll go over. Okay, and we've went over it in alkanes and alkenes. But let's use the formula first in order to come up with the actual formula of a compound. So for example, if we drew propyne, which looked like this, and the normal convention, right, to draw triple bonds is like that. Like you shouldn't draw, if we're drawing propyne, you shouldn't draw it like this because you don't want to draw the triple bond at a slanted angle like this. Whenever we're drawing triple bonds, it has to be straight like the one above. Okay, so if we look at propyne, right, and we number the carbons so that the carbon number is on the least, or so that the triple bond is on the least carbon number, so we'd actually name it like this. So in reality, this would be 1 propyne, but that's being over specific. We can just write down propyne, right? But if we're trying to find like the formula of this, so if someone asks you, okay, give me the formula for propyne, you know prop prefix means 3, and you know it's an alkyne. So because you know it's 3, you can use that formula right away, which is CnH2n minus 2, and where n is equal to the number of carbons in your molecule. So in this case, propyne has 3 carbons, right? So it'd be C3H2 times 3 minus 2, which is C3H4. And so that would be the formula for propyne. And we can check that because we can go ahead and fill out the imaginary hydrogens in this line diagram. So the imaginary hydrogens would be right here. 1, 2, 3 for this, right? Let's just draw it like that. And we're just going to draw the orange lines instead of writing the hydrogens to save time. So the orange lines represent hydrogens, right? And then this carbon right here, so the one I'm drawing the dot in, right, because these two are carbons in a line diagram. This carbon right here already has 4 bonds. 1, 2, 3, and then 4. So you would not have any hydrogens for that carbon. This carbon has 3 bonds. 1, 2, 3. So we would only have 1 hydrogen for this carbon. So how many hydrogens is that? That's 1, 2, 3, 4. So we have 3 carbons and then 4 hydrogens, right? So you can use this formula in order to find out the actual formula of a compound, or you can straight find this formula, right, without using this formula. So if we just looked at butyne, for example, and we drew out butyne, which would look something like this, you can check that because there's 1, 2, 3, 4 carbons. Okay, so if we numbered this just for practice, it would be like this, because you want the carbon number, you want the triple bond on the least carbon number, so that this would be 1 butane, but we'll go into naming alkenes in the future videos. For right now, let's come up with the formula. Let's come up with this formula, right? The actual formula of the compound without using this formula. So you can just, if you already know it's butane, which is 4 carbons, right away you know it's C4. Now you just need the number of hydrogens, which you can find out by fulfilling the octet rule for each carbon. So let's start with this carbon. How many bonds does this carbon already have? 1. So how many bonds more does it need to get to 4 bonds? 3 more, right? So those 3 are going to be to hydrogen. 1, 2, 3. We're not going to draw the hydrogens in, of course, to save time. So just know that the orange lines represent hydrogens. Now if we move on to this carbon, how many bonds does this carbon have? 1, 2, so it needs 2 more bonds to fulfill the octet rule. This carbon already has 4 bonds, because 1, 2, 3, that's part of the triple bond, and then 1 bond here. So that this carbon needs no hydrogens, because it already has 4. This carbon has 3 bonds, 1, 2, 3, so it needs 1 more bond in order to fulfill the octet rule. Okay, so how many hydrogens is that? Let's count the orange lines. 1, 2, 3, 4, 5, 6. So that's C3H6. Now, if you wanted to, you can check this formula of this compound with the formula that we came up with in the beginning, which is CnH2n minus 2. N is the number of carbons, which we know it's 4, so it'd be C4H2 times 4 minus 2. So that'd be C4, and then what's 2 times 4 is 8. What's 8 minus 2 is 6, so H6, right? And so as you can see, these two are the same formula. All right, so that's the basic intro for alkynes, right? And in the next few videos, we're going to start doing practice problems in terms of naming alkynes. All right, so I hope to see you guys there.